Lesson 1.9, Direct Variation. Direct variation is a linear relationship in a direct variation when the ratio of y to x is a constant k. We say y varies directly with k. So, to represent it mathematically, we take y over x. Again, we always have y over x, and that's going to equal our k, our constant. What are we changing by? Or that's the same thing as y equals k times x, where y or k can never be 0. So an example, y equals 3x. So our direct variation here would be 3. We're changing by 3 every time. When two variable quantities have a constant ratio, the relationship is called a direct variation. The constant ratio is called the constant of variation. The constant of variation is also known as the constant of proportionality. So direct variation, constant of variation, and constant of proportionality are all the same thing. In a direct variation equation, the constant rate of change, or slope, is assigned to a special value k. So again, direct variation is the same thing as slope, which is the same thing as our constant rate of change, which is the same thing as our unit rate. So what are we changing by every time? So if we go down to example A, 2 minutes after a diver enters the water, he has descended 52 feet. After 5 minutes, he has descended 130 feet. At what rate is the scuba diver descending? Okay, so again, when we set up our direct variations, it's always y over x. So if we were to plot these, we would say we have point 2, 52, and 5, 130. Again, I want my y over my x, so I take 52 over 2, 130 over 5, and then I have to simplify these. So what goes into 52 that goes into 2? Well, I could take out 2. I'd have 26 over 1. Then 130 over 5, I could take a 5 out. Again, I'd have 26 over 1. So we would say the rate it is descending is 26 feet per minute. So again, it's like our slope, our constant rate of change, our unit rate. What are we changing by every time? This scuba diver is going down 26 feet every minute. Okay, if we look at example B. The distance y traveled in miles by the Chang family is x hours is represented by the equation y equals 55x. Identify the constant of proportionality, then explain what it represents. So again, when we have our equation is y equals k times x, and k is always our constant. So when we look at our equation, y equals 55x, we know that our constant of proportionality is 55 because that represents our k value. So we would say the constant of proportionality is 55. And then we have to explain what it means. That means they travel 55 miles per hour. Okay? So they are going 55 miles every hour on their vacation. Okay? So determine the direct variation. Not all situations with a constant rate of change are proportional relationships. Likewise, not all linear functions are direct variations. Okay, so not every time is it going to work. So if we go down to example C. 2 pounds of cheese cost $8.40. Show the cost of 1, 2, 3, and 4 pounds of cheese. And is there a direct variation? And explain. Okay, so again, when we set these up and we put our y over x, do they simplify down to the same thing every time? Sometimes that will not work. So again, they asked us to find if there's a direct variation. And we need to show a cost of 1, 2, 3, and 4 pounds of cheese. So I'm going to go up to our graph here. We have 1, 2, 3, and 4 pounds. And it told us that 2 pounds is $8.40. So we need to figure out how much would 1 pound be, 3 pounds, and 4 pounds. Well, to figure that out, I would figure out how much does a pound cost here. So I would take 840 over 2, again, my y over my x, and simplify it, and it would simplify down to 420 over 1. So I know 1 pound is 420. And then I could take that times 3 to figure out for 3 pounds, which would be 1260. And 4 pounds, which is 1680. Okay, and then I'm going to graph it. And then I would connect my points here. So again, we can look at these different ways. We could figure out from our table, we could simplify all these down. Do they all simplify down to $4.20? We can look at our graph. Again, when we look at our graph, is it a straight line? And does it go through the origin? Yes, it does on our graph. So we would say there is a direct variation. If we simplify all of these down, we did 840 over 2, 1260 over 3 simplifies to 420 over 1, and 1680 over 4 also simplifies to 420 over 1. So we would say, yes, there is a direct variation. And then it asked us to explain. It is $4.20 per pound. So no matter how many pounds of cheese you buy, it's always going to be $4.20. So again, a direct variation is like your slope. It's like your constant rate of change. It's like your unit rate. What are we changing by every time? And you've got to make sure you're checking to see if you have a direct variation, because sometimes there isn't one.